Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is capacity modeling, the next milestone in performance engineering. Our guest speaker today is Mr. Uday Kumar VR, Center of Excellence Head, Performance Engineering, Test Automation and Service Virtualization at Wipro Technologies. Uday has more than 12 years of experience in various facets of performance engineering, SOA testing and service virtualization. He has been an active member in Thought Leadership Group for Service Virtualization and Performance Engineering at Wipro and heads the Center of Excellence. The organizations he has worked with in the past include Devon Technologies, LG CNS Global and SunGard. He had been the editor-in-chief of the performance newsletter called Performance Booster and had successfully rolled out 300 plus editions in Wipro and still going. He had been actively designing workshops for upcoming service virtualization practitioners and performance engineers, bringing in experience from various domains like BFSI, telecom and retail. So without further delay, I introduce you all to our guest speaker. Over to you there.
All right. Are you sharing the presenter mode, Mohini?
I have done that.
Thank you.
You can share your screen.
Thank you. Hello, everybody. Good afternoon to all people in India and people from good morning and good evening for people around the globe. So this is a seminar or a session on capacity modeling, which is the next milestone in performance engineering, and we have a target audience towards the performance engineers, capacity planners, or infrastructure planners. So this is eventually being now looked at a very essential item in any performance testing lifecycle. So I had the Center of Excellence in Wipro for performance testing, engineering, automation testing, service virtualization. So I'm going to talk about a few of the theories before we get on to the capacity planning per se, and then we'll take some questions. So if there are any questions, you can actually log into your question section and you can type in the question, and I'll be glad enough to answer these questions at the end of that. However, I would suggest to park your questions before you type in there. You might get answer as we in the due course of the presentation also. All right. Thank you very much. So we'll proceed further. So let's first look at the agenda or the contents that we are going to have today. We'll have an introduction, obviously, to understand, to get the context of the presentation. We'll have some amount of theory around what is a capacity planning. In general, it's all about how to plan your infrastructure capacity in the production. And most of the times, the people who validate whether the infrastructure is okay for this kind of load, for example, 100 users, 1,000 users, 1 million users, the people who validate and tell is the performance testers and engineers. So when you plan for a capacity like an infrastructure, you would definitely need the output from these performance testing validation. So let's look at the theory part of it. Then we'll see how it is done in a lab. For example, I'm going to tell you as to how did we do in the lab and the process of capacity planning, which is again an abstracted theory of how did we do, and few guidelines around capacity planning. So I'll be happy if there is any amount of takeaway in terms of how do you do the capacity planning and modeling. And it is how it is a part and parcel of a performance testing engineer lifecycle. All right, let's go forward. Now, first of all, to understand the capacity planning, you need to understand which are the key performance needs or key performance queries that is actually pushing you towards the need for the performance capacity planning. The few of the questions that I flashed you on the screen, like will the application perform in the production the similar way? How many of you as a performance engineers, you had been actually boggling with this kind of question saying that it had worked in a very lower end environment, but how will it perform in the production where the environment is also at a high end and at the same time the load is also very at a higher end. So you cannot have a complete realistic performance testing in the lab or a pre-prod environment. So these questions have to be answered. Now, where are the potential bottlenecks in the application? While you do during the performance testing and engineering itself, it's important to know that if the load is now exponentially increased, which is the first bottleneck that you would be arriving upon. So that you would know only when there is an extrapolation that you can do. Third bullet, can this application meet the required service levels? Straightforward question. Will a change in one application or an infrastructure component cascade to performance problems? The point is, like, I not only mentioned application, I mentioned infrastructure also. Let's take an example of a client, a web server, an app server, and a DB server. Let's assume that I have 20 web servers, and I'm going to probably put it into 10 web servers. I'm going to consolidate web servers into 10, which means because in all the web servers, I'm not seeing the very appreciable utilization, so I wanted to consolidate. So if I do that kind of a change, as a performance engineer, would you be able to extrapolate whether it's going to really work with the same SLA or a similar kind of SLAs? Then, which hardware solution best meets the performance and goals? Very simple. Should I buy a Dell server, or should I buy an IBM server? Should I buy a Pentium, or should I buy a Xeon, or should I buy an AMD Anthlon? So these kind of hardware solution, whenever the hardwares they release into the market, they produce something called as a TPCC benchmarks. You can look into the Google and find out what they are. So these benchmarks tell how do these hardwares perform. For example, AMD Anthlon, for example, Intel's Xeon server. So they test on a very standard application, starting from web application to any client server application, and tell you as to what benchmarks do these hardware have. Now, before even buying an infrastructure or planning for capacity, you're going to buy, let's say, 50 servers and 70 data centers, and so many virtual machines and so many cloud VM instances. So you've got to understand as to the nature of the hardware also, because it means a lot for the performance. Now, how can the service level agreements be met without overburning our infrastructure? So overbuilding our infrastructure. So this is something that we have to look at the consolidation part. For example, I don't want to buy infrastructure, but I know there are as many as 150 servers in my data center which is not used. So can I actually try to consolidate few servers into one and then try to use the idle servers for the application? So that is another service level agreement maintenance and management. Then what is the maximum workload the application and the supporting infrastructure can handle? Like this you can do for as a load testing or a performance testing. But if you are using a commercial tool, you are handicapped with the licenses if you're buying an open source tool. However, open source tools like JMeter might not support more than so many users for a little heavy-weighted web application. So you would still want to do some kind of extrapolation and see whether this application / infrastructure would support that kind of load. So these are the kind of queries, and I wanted to set this as a context before understanding capacity planning. I'm sure you all would be having a different kind of understanding of what they are, but however, this is the context that we would be sailing upon for the next 45 minutes. Now, let's look at the current scenario. Yeah, it's flashing on your screen. So now if you look at it, there's a pre-production and there's a production. Pre-production, or otherwise you call it as a performance testing environment, and there's a production. So once you keep finding, do the various experiments in performance testing environment, you test with multiple users, and you do a diagnostics, you drill down and find bottlenecks, and then you try to fix it, or you can see the connection pools, memory leaks, or it could even be so much of a log writing, so much of disk IO. So once you fix it up all, now you are still not aware, and there is definitely a factor of nervousness when you deploy this application in the production. So before you deploy it in the production, you will have to do something in between, and that is where your capacity modeling fits into. So this is something that I wanted to tell you, to just tell how do we position our capacity managers position in the whole of the testing life cycle. So if you look at this, the capacity modeling comes exactly in between to tell it does a projection, it does a modeling, it just predicts the behavior, and it also tells about what would happen if there is an infrastructure change. And it will also tell whether I'm actually getting the revenue or returns on the investment that I made for the infrastructure, which is I have so much and so much I have invested. Do I get the equivalent performance to this? So this is what is going to be the theory and the science of capacity modeling which we are going to do. So this is the positioning. On top of that, I've also mentioned on the flash sync which are the typical tools that you use to just give another context as to what we are talking about. So in the production, we use CA Intrascope or HP SiteScope or HP OpenView Manager. So lots and lots of tools that we use. So this is something which is little close to people who are aware of what erstwhile tool called high performance. It's actually a capacity modeling tool wherein that was using more of a load runner performance testing results. Now this is completely standardized, and you can use any tool and you can still do a kind of a capacity modeling and capacity planning. So we'll come to know which tool we are talking about in the latest part of the session. Now look at that. Look at the circle inside and just concentrate on the 5 balloons out there. So these are the typical questions that we would be looking at in this due course. Infrastructure change, the first balloon. So do I have a correct hardware, which means am I having something, do I have a right set of RAM size, right set of disk IO, right set of, CPUs and RAMs. So that is the infrastructure that you wanted to validate. All right. And the second is response time prediction, as you see on your right-hand side balloon. So most of the times you would wanted to see whether the response time at 50 users is so and so. What would the response time be at 500 users? So here in this capacity modeling theory says you cannot actually directly focus that way. However, at the process level, which means let's say if a Java application is running and you see java.exe in your task manager, which is the process or a daemon. Now, there are many instructions this java.exe executes, and these instructions, the response times are gathered, and those response times can be predicted exactly when what happens when the load increases. So, what I wanted to tell you is, please let's not confuse this response time with the end-to-end transaction response time as you see in the load runner. Rather, it is the instruction execution time at the process at the daemon level. So that is what a capacity modeling should be used for. Very simple, because a response time, end-to-end response time includes so many factors like a server, the network, and the disk IOs, and so many factors which cannot be included in capacity modeling. So that is the second balloon. Then the third one after response time, which is workload consolidation. As I mentioned there, can I merge these two app servers into one? This is something like infrastructure engineers would be looking forward. Most of the customers that we have, they have thousands and thousands of servers. And if you look at the kind of utilization of these servers, I'm sure that more than 60 to 70% of the servers would be underutilized. So there is actually an imbalance in the server farm that the customers provide. So in that case, instead of going and buying a new server for hosting a new application, now infrastructure engineers can make use of this science and then understand as to can I use the existing hardware itself by consolidating the other unutilized or less utilized servers. So that is workload consolidation. Then the test to production, which is pretty straightforward. How do I compare the results of test environment, which is in this case a performance environment, to the production environment? Then the workload change. For example, let's say there is a retail application like eBay, which is having a constant load, and all of a sudden during Christmas time, we call that as a holiday readiness. During Christmas time, there is a huge load on the server and infrastructure. Now, if there is such a kind of a spike and such an exponential spike, will this particular application handle? So this is a dramatic change of the workload. Now, these are the 5 different contexts that you have to keep in your mind. And as a performance engineer or an infrastructure engineer, if you could add these details in your CapEx or OpEx, which means capital expenses or operational expenses plan, then that would be adding more value to the stakeholder discussion and document committee. So this is the kind of perspective which we would again sail upon. Now let's look at the